Good day, class. Today we're going to be picking up where we left off after day one. And we are in topic 2 in our textbook, although this is topic 4 overall in the actual class. So we'll start off with cumulative frequency. A cumulative frequency graph is particularly useful when trying to calculate the median of a large set of grouped discrete data or continuous data. When trying to determine how consistent a set of results are, calculating the cumulative frequency is done by adding up the frequencies as we go along. All right, so looking at an example, all right, the duration of 2 different brands of battery, A and B, is tested. 50 batteries of each type are randomly selected and tested in the same way. The duration of each battery is then recorded. The results of the tests are shown in the tables below. All right, so here are all of the results. All right, and this is in your textbook on page 81. All right, so here they have it grouped. Right, so any battery that lasted between 0 and 5 hours, not including 5, all right, was put in this group. 5 to 10, 10 to 15, so on and so forth. All right, so there were 3 batteries that were lasted within this range, 5 within this range, and so on. All right, now the cumulative frequency you get from adding them all up successively, right? So the first group had 3, so it has 3. All right, the second group has 5. Well, 3 and 5 together, whoops, didn't mean to do that. All right, 3 and 5 together make 8. All right, and then the next group has 8, so 3, 5, and 8 makes 16. The next group has 10, so these were 16 plus 10 is 26. Add 12 more, add 7 more, add 5 more. Of course, your final cumulative frequency should be your sample size. In this case, they said there were 50 battery brands of each type. All right, so A, all right, plot a cumulative frequency curve for each brand of battery, and B, estimate the median duration for each brand. All right, so let's go ahead and add an extra slide here. All right, now going back here, all right, basically we're going to need a set of points. We're going to be graphing points essentially. All right, we always use the upper bound of our range, all right, and the cumulative frequency. All right, so this will be my x coordinate, this will be my y coordinate. All right, so we'll go ahead and do type A first, and we will get some axes going on here. All right, so we know that our cumulative frequency is going to be 50. So I wish I could have done more, but that'll suffice. Maybe not. I want this to be bigger. Oh, no. All right, so each one of these will be worth 5. All right, our duration goes up to 35, so All right, so again, it's all from this data. So if you want to follow along in your book as I make this graph, so my first point would be 5, 3, and then 10, 8, 15, 16, etc. All right, so first, 5, 3 would be somewhere in here. And I'll make this a different color just to make it a little bit easier. All right, next we have 10, 5. Then we have, oh, I'm sorry, that should be 10, 8. So 10, 8, somewhere in here. Then we have 15, 16. So somewhere right in here. Then we have 20, 26. So somewhere up here. Then we have 25, 38. So 25, 38, somewhere in here. Then we have 30, 45. So up here. And 35, 50. All right, now we always start from 0, 0. We connect these with a nice smooth curve. It's hard for me to do a nice smooth curve on this little tablet that I'm using. All right, so it should look something like that. Hopefully drawing it by hand would be much nicer. All right, and then it asks us to find the median. Well, there's 50 entries. There's 50, our sample size is 50. So half of that is 25. All right, so what we would do there is go from 25, and we would go straight horizontally until we hit our curve. All right, and then we come straight down. All right, so looks like 19 or 20. All right, we'll call that 19. So my median would equal 19. All right, now we want to do the same thing for battery brand B. And what I didn't do, that you always want to do when you're drawing graphs, is label your axes, really label everything, right? So this would be battery A. Oops. This will be battery B. All right, over here, let's see, it might be a little bit easier. This. All right, so this axis over here would be cumulative frequency, which really should be off over here to the side, but I don't have any room. And then down here, this would be duration. All right, so same thing over here, you would say cumulative frequency. Down here, you would say duration. All right, so I'll do the same thing here. So these are all 5 apiece again. And these are also 5 apiece again. All right, so now using our data that was on the last slide, we would have 5, 1, and I will use a different color here. Let's go purple. 1 would be somewhere here. Then we have 10, 2. Not very much going on there. And then we have 15, 12. So up here somewhere. Then we have 20, 35. So way up here. And then 25, 44. 25, 44 somewhere right here. 30, 48. So somewhere up here. And 35, 50. So again, we start at 0, 0. We try to connect these with a nice smooth curve. All right, again, not very good on this little tablet pen I'm using, but you get the point. All right, so if we want to find our median again for this set, right, we go from 25 until we hit our graph, and then we come straight down. All right, so this would be not too far away from the other one, but it looks like my median here might be 18 or 19 again. And when you draw your own graphing stuff, as long as it matches your own, like your graph, as long as your graph isn't completely and utterly terrible, they're pretty lenient on that. Like if you said 18, if you said 19, this probably should have been over a little bit more, which is why I said 18. But that's not. You don't have to split hairs there with that. IB knows that it's a hand-drawn graph. So, all right. The cumulative frequency axis can also be used. Can also be represented in terms of percentiles. Okay, so a percentile divides the cumulative frequency scale into hundredths. The maximum value of cumulative frequency is found at the 100th percentile. Similarly, the median, being the middle value, is also known as the 50th percentile. In addition to these, the cumulative frequency scale can be divided into quarters. The 25th percentile is known as the lower quartile, or Q1, while the 75th percentile is known as the upper quartile, Q3. All right, so really, if you wanted to go halfway between 25 and 50, which would be 37.5, right, you could come up here and go over, and that would be your Q3. You could go halfway between 0 and 25 is 12.5. Come over here, that would be your Q1. And of course, you could do it over here as well. All right, so far we have seen how cumulative frequency curves enable us to make estimates of the median and quartiles of grouped data. All right, box and whisker diagrams provide another visual way of representing the data. All right, the following diagram demonstrates what a typical box and whiskers diagram looks like and also highlights its main features. Okay, so I'll kind of show you what one of these may look like. Just get it dotted. Ignore that little arrow on the end. We don't need that. It doesn't look straight anyway. Son of a biscuit. All right. All right, so this is what a typical box and whisker diagram might look like. All right, so here, all right, so right here, all right, this end would be Q1, your lower quartile. Right here, this end of the box would be Q3, the upper quartile. This dotted line in here would be your median, right? And it doesn't have to be right in the middle. It can, depending on what your data is, right, can be skewed one way or the other. All right, this little piece over here, all right, would be your minimum value, so the lowest value of all of your data. And over here, this would be your maximum value of all of your data. So that's what a typical box and whisker diagram looks like. The box and whisker plot diagram shows the main features of the data. All right, indicated example, the minimum and maximum values, the upper and lower quartiles, and the median. The box represents the middle 50% of the data, which we call the interquartile range. Right? And the whiskers represent the whole of the data, which is the range. Right? For discrete data, the median position is given by the formula n plus 1 over 2, where n represents the number of values, your sample size, if you will. Similarly, the position of the lower quartile can be calculated using n plus 1 over 4, and the upper quartile by the formula 3 times the quantity n plus 1 over 4. So do kind of keep those in mind. All right, the shoe sizes of 15 boys and 15 girls from the same class are recorded in the frequency table below. So here it gives us all of our data. It says A, calculate the lower quartile, mean, and upper quartile shoe size for the boys and girls in the class. B, compare this data using two box and whisker diagrams, one for boys and one for girls. And what conclusions can be drawn from the box and whisker diagram. All right, so what we're going to do here is add a slide for our box and whisker diagrams. All right, so we're using all of this data before. Right, I will use blue for boys. All right, so first we need to find the median. All right, well, that is n plus 1 over 2. Right, well, it tells us that there's 15 boys and 15 girls, so my n is 15. So 15 plus 1 over 2 is equal to 8. Now what that tells me, not that 8 is my median, but that my 8th term is my median. So if we go back and look at our data, all right, for boys, I have 0, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So my 8th term is one of these three. So it's shoe size 8. All right, now we want to do Q1, which is n plus 1 over 4. Well, my n is the same, right? So we have 15 plus 1 over 4. Again, 16 divided by 4 is 4, but 4 isn't the Q1, it's the 4th term. So when we go back and look at our data, 0, 0, 1, 2, 3, 4. So size 7. Q3 is 3 times n plus 1 over 4. So this is 3 times 16 over 4. So 16 over 4 is still 4, times 3 is 12. So this is the 12th term. All right, so that is going to give me 3, 4, 6, 9, 10, 11, 12, 13. So my 12th term is here at size 8.5. All right, now of course, our minimum value for boys is 6, and my maximum is 9.5. All right, that's all of the data we need to make a box and whisker diagram. All right, now we'll go ahead and do the same thing for girls. All right, now the girls also have 15 girls, so n plus 1 over 2 is still 16 over 2, which is my 8th term for girls as well. So when we go back and look at the girls, we have 1, 2, 3, 4, 5, 6, 7, 8. So the 8th term is shoe size 6. For Q1, we do the same thing, n plus 1 over 4. Again, my n is 15, so this is 16 over 4, which is the 4th term. So my 4th term here, 1, 2, 3, 4, is 5.5. So size 5.5. Q3, same thing, 3 times n plus 1 over 4, which is equal to 3 times 16 over 4, which is my 12th term. Which for girls, we have 1, 4, 8, 12, so 6.5. All right, now we also want to know our min and our max. For girls, our minimum is 5, our maximum is 8. All right, and it wants us to do a box and whisker diagram for both of these. All right, so we can just do, really you only need a horizontal axis for box and whisker diagrams. You do not need a vertical one. All right, so here's 5, 6, 7, 8, and 9. All right, so the boys' box and whisker plot I'll do in blue. All right, so my box is going to be from 7 to 8.5. So I draw a box from 7 to 8.5. All right, the median is going to be at 8. So I come here to 8. There's my median. My minimum is 6. So off here somewhere, there's my tail. And my maximum at 9.5 over here. There's my other tail. So there's a box and whisker plot for the boys. All right, for the girls, whoops. All right, our Q1, our box goes from 5.5 to 6.5. So 5.5 to 6.5. All right, the median is 6. So I come down here to 6. Right, the minimum is 5, so over here. And the maximum is 8, so up here. All right, so there's our box and whisker plot for the girls' shoe sizes. All right. Now going back, it said what conclusions can be drawn from the box and whisker diagrams. All right. Well, not surprisingly, in general, boys have the bigger feet. All right. However, the interquartile range, the middle 50% of the boys, is kind of spread out and a little lopsided, whereas the girls is much more compact and symmetrical. However, the girls do have a significant outlier here. It's size 8, right? Um, whereas in general, although the inside of the boys is a little bit skewed and lopsided, the overall data is somewhat symmetric, right? Whereas the overall data here is not. So those are just a couple of observations. All right, on page 88 in your text, you can look at directions on how to create a box and whisker plot on your calculator. All right, I'll go ahead and show you how to do that here. All right, so first thing you do is you hit second y equals to go up to this stat plot option here. All right, so you hit enter and turn this on. You come down to type, and obviously the box and whisker plot looks like right there. All right. My X list will be L1. My frequency list is going to be L2, so I have to hit second 2 for L2. And blue is fine because that one's going to be my boys, so I'm good there. All right. I can go back to stat plot because we have 2 of them. So I'm going to plot 2. I'm also going to turn this on. Come down again, go to my box and whisker, hit enter there. My X list is still L1, that's just my shoe sizes, but my frequency list is actually going to be, I'll call that L3 for the girls, and red is good for girls. That's what I did with my colors anyway. So we can now quit out of here. All right, now we want to hit the stat button and hit enter on edit. That will bring us up to all of these lists. All right, so now we're going to put all of this data in here. Well, my shoe sizes, we have 5.5, 6. Oh, whoops, I'm sorry. We should have started with just 5. 5.5, 6, 6.5, 7, 7.5, 8, 8.5, 9, and 9.5. All right, now our boys will put in L2. All right, and that data, we have 0, 0, 1, 2, so 0, 0, 1, 2, 1, 2, 3, 4, 1, 1. All right, girls, which we will put in L3, is 1, 3, 4, 4, 1, 1, 0, 0, 0. Okay, so now all of our data is in there. All right, now we're going to want to kind of mess with our window here. Remember, we only really care about the horizontal scale. We don't care about the vertical. So our lowest shoe size was 5, but I'll go ahead and say like 4. My highest shoe size was 9.5, so maybe I'll say like 11, just to give us a little bit of room on the outside, on the margins. All right, my scale, we actually want that to go by halves because we have half shoe sizes, right? So now when I go ahead and hit graph, boom, there are the 2 box and whisker plots, right? Which if we kind of go back over here, look very similar to ours, other than, blue being on top here and blue being on bottom here, but verticality means absolutely nothing with box and whisker blocks. So good times, good times. All right, measures of central tendency. All right, average is a word which in general use is taken to mean somewhere in the middle. For example, a woman may describe herself as average height. A student may think that he or she is of average ability in math. All right, mathematics is more precise and uses three main methods to measure average. All right, mean, median, and mode. All right, mean is the average, median is the middle entry when put in order, and mode is the one that occurs most often. Obviously, I'm not going to spend a whole lot of time on this. This is like, 5th grade, maybe even before stuff, right? So the numbers below represent the number of goals scored by a team in the first 15 matches of the season. Find the mean, median, and mode of the goals. So we want to put these things in order. So we have 1, 2 zeros. We have 1, 2, 3, 4, 5 ones. All right, we have 1, 2, 3, 4 twos. We have just 1, 3. We have 1, 4. And we have 2 5s. Let me make sure I have the same number here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. All right, we're good. So the mean, all right, all we do is add all of these things together and then divide them by the 15 that there are. So we have 1, 2, 3, 4, 5, 7, 9, 11, 13, 16, 20, 25, 30. So 30 divided by 15, my mean is 2. Right? The median is the one in the middle. All right. Remember, that's n plus 1 over 2. So there's 15. So 15 plus 1 over 2, that's 8. So my 8th entry is my median. So 1, 2, 3, 4, 5, 6, 7, 8. So that is 2. And the mode, the one that occurs most often, there are 5 ones, only 4 twos. So 1 is my mode. Pretty tough. All right. See page 91 in your text for directions on how to find these and other useful statistical measurements on one variable stat. So if we go here, all right, and I pull out my calculator, all right, I'm going to go ahead and turn these stat plots off for now. And I'm going to go back to my stats and edit. Okay, now I don't need all of this stuff. All right, I only have one set of data here to put in. All right, so to clear out a whole list, you go up to the top. Do not hit delete. If you hit delete, you'll delete the whole L3 and it'll no longer be there. All right, so what you want to do is you want to hit clear. And then when you come back down, it clears that list out. So go up to L2, clear, bam. Up to L1, clear, bam. Okay. So the data for this, all right, we can put in L1, all right, and the data given to us was 1, 0, 2, 4, 1, 2, 1, 1, 2, 5, 5, 0, 1, 2, 3. All right, well, if you go back to the stat option here, if you go over to calc for calculate, you'll see the first thing is this 1-bar stats. If you hit enter there, we have all of our entries into list 1. There is no frequency lists, so you leave that blank. Come down here to calculate. All right, this is all sorts of interesting stuff. This X bar, right, that's what it's called, literally is X bar. All right, that is the mean, so my average is 2. That's what we found. All right, we'll talk about some of this other stuff later. All right, but N is 15. That's how many entries we have. My minimum value is 0. It even gives us Q1, Q3, my maximum. Here's my median, which we also found to be 2. The only thing it does not give you is mode. So do be mindful that it's not going to give you the mode. However, mode is super duper easy. This is also very useful, all of this, if you're doing a box and whisker plot by hand, right? This is literally the 5 pieces of information that you need to do a box and whisker plot. Right? Large amounts of data. When dealing with large amounts of data, use the GDC to find any required statistical measurements. Use the directions, Okay, so when given frequencies, it's really no different. You would just put your frequencies into list 2, and then when you go to your calculator to do the 1 variable stat again, right, you would actually just frequency list down here, you would hit second L2, and you would take care of that. All right, mean and mode for grouped data. As has already been described, sometimes it is more useful to group data, particularly if the range of data is very large. However, by grouping data, some accuracy is lost. The results below are the distances to the nearest meter run, that should be by 20 students in 1 minute. All right, so it gives us all of this data here. And then it gives us some different possible groupings. All right, so here we have, basically 5-meter intervals. All right, here we have 10-meter intervals. Here we have 20-meter intervals. All right, so, all right, the 3 tables above highlight the effects of different group sizes. Table 1 is perhaps too detailed, while in Table 3 the group sizes are too big, and consequently most of the results fall into one group. So that's saying that those aren't necessarily great. Now, too detailed isn't bad, right? But if you're going to be that detailed, and like you have lots of ranges with 0s and 1s and 2s, then don't even group it. Just use the whole data set individually. Right, so if you're going to be super too detailed, just use the whole data set. And then, so basically this one, as you can see, most of the data falls within one category, so that's definitely not a good way to group the data. So if you're going to group it, group 2 is definitely the way to go. And this is just some more explanation on that. All right, now, all right, in the 270 to 279 group, we can see that there are 8 students, but without the raw data, we would not know where in the group they lie. For this reason, all elements of a particular grouping should be assigned the mid-interval value when calculating statistical measurement, right? So if you're trying to find the median or the mean, and all you have is the grouped data, now if you have the original data, then use that. But if all you have is grouped data, you have to use the mid-interval, right? So halfway between 270 and 279 would be 274.5. So you essentially would say that all 8 of these students did 274.5. The GDC can work out the mean, median, and quartiles of the grouped data. the mid-interval value should be used for all elements in a given interval. All right, measures of dispersion, all right, range in the interquartile range. The range of a distribution is found by subtracting the lowest value from the highest value. So the maximum minus the minimum. That's how you find the range. Sometimes this will give a useful result, but often it will not. A better measure of dispersion is given by looking at the spread of the middle half of the results. Basically, that's because it kind of will exclude any and all outliers that could skew your data. All right, this is found by finding the difference between the upper and lower quartiles. All right, so the interquartile range, which you will often see as IQR, right, we find that by doing Q3 minus Q1. Basically, this worked example on page 98 just looks at those same cumulative frequency curves that we made earlier from batteries A and B. And basically, it just uses those curves to find Q3 and Q1 and subtract those to get the interquartile range. All right, the standard deviation of data as a measure of dispersion that does take into account all of the data. It gives an average measure of difference from the mean of the data. The larger the value of the standard deviation, the more widely spread or dispersed the data is. Standard deviation is what's used all the time. All right, so it's a very important measure of dispersion. All right, for example, the ages of two groups of people are given below. All right, A, find the mean, median, and mode of each group. We could just use our calculator for this, right? If you just plug this into your calculator. All right. So here, and I just kind of put these in my head real quick, but you could definitely use your calculator. All right, the mean is going to be 16. All right, the median, so going in order, right, there's 8, so it would be halfway between 4 and 5. The average of these two is also 16. And then the mode, the one that occurs the most, the only one that's repeated is 16. All right, here, mean, 30 and 2, 32, that's 16 average, and then everything else is 16. So this is also 16. Median, obviously all of the ones in the middle are 16, and the mode obviously is 16 also. All right, find the mean, median, mode of each group. We did, they're all 16, not very interesting. What do these measures suggest about the data? Well, if we didn't have the raw data, right, if we weren't looking at the raw data and we were only looking at mean, median, and mode, right, you would say that really there's no difference between these sets of data. All right, since all of them are the same. All right, the formula for standard deviation of a set of data is given by this. All right, do be mindful, this symbol here is called sigma. It's a Greek letter, right? But in mathematics, that means summation. That means you add a bunch of things together, right? So you take every x, you subtract the average, and then you square it, and then you add them all up. That's what this symbol means. And then you divide all of that by n, which is the total number of data points, right? Which all of that is here. So find the standard deviation of each of the previous groups. What does this say about the dispersion of the groups? All right, so I basically am taking the square root. So first I'll do of group 1. All right, so it's going to be the square root. Now, my mean is 16, so I would do 2 minus 16, which is negative 14, and I would square it. And then 6 minus 16, which is negative 10, and I would square it. All right, and then 10 minus 16, which is negative 6, and I would square it. And then this would be 0, 0 again. 22 minus 16 would be 6. So 26 minus 16 would be 10. And 30 minus 16 would be 14. And you divide all of those by the total number of data points. Whoops, there's not 15 there. There's 1, 2, 3, 4, 5, 6, 7, 8. So we divide that by 8. All right, so if we actually do that in our calculator, all right, we will get 9.11. Right, if we did it for the second group, all right, well, here we do, my mean is 16 again, so 2 minus 16 is negative 14. Whoops, negative 14 squared. Now, all of these 16s, 16 minus 16 is just 0, right? So we're going to have a lot of zeros, which you wouldn't really have to write in here, but just for the sake of explanation. And then 30 minus 16 is 14, and that is 7. All right, so the larger standard deviation means that the data is more spread out or wider dispersed, which obviously makes sense, right? We can see that there's a lot more difference between these points of data than these points of data. All right, the formula previously given can be very tedious, right? Because you have to do all of those, right? There were only 8 data points there, right? So if I had a set of data with like 100 data points, you wouldn't want to write all of those out. So this is actually the much cleaner and more efficient way to use standard deviation. All right, your GDC can also calculate the standard deviation of data. All right, to do the standard deviation, all right, you really do kind of what we've already done before. So we'll just do it for this. These were the goals that were in there from that one example. All right, but if you just do calculate your one variable stats, all right, S sub x means the standard deviation of the x's, right? And that's what IB is going to call it. But what we actually want to use for it is this, all right? We're actually going to use this little sigma sub x. So although we call it S sub x, we actually use the value for this sigma sub x. So the standard deviation here would be 1.549, or really 1.55. IB is pretty consistent with wanting 3 significant figures, so that would be sufficient there. And that is it. All right, so do the homework from your textbook. Just do all of the exercises in each of these sections. All right, there's usually not very many there, and they're usually pretty quick, so this won't be terribly long for you. And that is it for the day.